So, welcome to my class. We are continuing on with measures of central tendency, and in that we are going to do partition values. And in partition values, we've already been introduced to median that divides the entire series into two parts. So, median is the midpoint. So, in that way, we have what is known as quartiles, decile, and we have percentiles. So, now what are quartiles? When the series is divided into four equal parts. What are deciles? Deciles are when the series is divided into 10 equal parts. So we have, and what are percentiles? When the series is divided into 100 equal parts. I don't know if it is so important for you in the syllabus, but still one should know about it. So quartiles, four parts, Q1, Q2, Q3. So when you divide a series into three parts, you get at three places you will get four parts. In the same way, when you divide the series into partition into 9 parts, you get 9 places, you get 10 parts. And in the same manner, when you do it into 99 places, you get 100 parts, 100 equal parts. So once again, quartiles, deciles, and percentiles. So let me just reiterate what I've just told you, that partition value, we've already know that median divides a statistical series into two equal parts. And before we go on, just remember the series have to be arranged in ascending or descending order. I particularly like to arrange my series into ascending order. But suppose if a descending order is given, then don't spoil the order. It's okay. Then you can go ahead straight with it. But if the data is not given in the ascending or descending order, the first thing that you have to do is make the series into ascending or descending order. Now, what are quartiles? So, okay, let's just talk. What are partition values? If you want to define that partition values are which divide the series. If they divide into two parts, it's median. If it divides into four equal parts, they are quartiles. And partition values that divide a series into 10 equal parts are known as deciles, and those dividing a series into 100 equal parts are known as percentiles. Let's just take the quartiles. When a series is divided into four equal parts, the last value of each part is known as a quartile. So there are four quartiles in each series, Q1, Q2, Q3 and Q4. Second, that is Q2, is median, and the fourth quartile is the last value of the series. Therefore, in practice, only first and the third quartiles are used. And talking about quartiles, because that is important, you might get a question. That further, let me just explain. The first quartile is denoted by Q1 or the lower quartile, and it has 25% of the items of the distribution below it, and 75% of the items are greater than it. Now the second quartile is denoted by Q2 or median, that has 50% of items below it and 50% of observations above it. And the third quartile is denoted by Q3 or upper quartile, has 75% of the items of the distribution below it and 25% of the items above it. Thus, Q1 and Q3 denote the two limits within which the central 50% of the data lies. Okay, now, what are deciles? When a series is divided into 10 equal parts, then the last value of each part is known as a decile. There are 10 deciles in a series, which are symbolized as D1, D2, D3, etc. And the 10th decile, that is D10, is the last value of the series. Hence, it is of no use. Therefore, in practice, deciles range from D1 to D9. This is what we use. Let's come to percentiles. So what are percentiles? they divide the distribution into 100 equal parts. So you can get 99 dividing positions denoted by P1, P2, P3, P99, etc. Now P50 is the median value. If you've secured 82 percentile in a management entrance examination, it means that your position is below 18% of the total candidates appeared in the examination. If a total of 1 lakh students appeared, so okay, so this is how percentiles are used like this to know where you actually stand. So now looking at this, now, let's just take the partition value Q1. Now there are three types of series: individual, discrete, and continuous series. Alright, so let's just take the first one, individual and discrete series, partition value Q1. You want to find out. So what do? It's exactly calculate. If you know median, by now you will be able to calculate this. Now for example, if you have this, Q1 is what? Individual or discrete series, n plus 1 divided by 4th item. In the individual series, n is the total number of items, and in discrete series is the total number of frequencies. So n plus 1 divided by 4th item, therein lies Q1. Q3, what is Q3? Now 3 into n plus 1 divided by 4th item, that is the size of Q3. Let's take decile 1. So what is this? Decile. Now in this, we have n plus 1 divided by the 10th item. Size of that lies as decile 1. And if you want D7, decile 7. So what is that? It is 7 into n plus 1 divided by 10th item. So this can be both in individual series and discrete series. In discrete series, just remember to use n as summation of all the frequencies. That's the only difference. Okay? And in the discrete series, again, another thing that you have to remember is you have to come out with cumulative frequencies, exactly the way you did with median. Alright? In the discrete series, that is. Now P1. What is P1? Percentile 1. So n plus 1 divided by the 100th item. That'll give you the P1. If you want P20, then 20 into n plus 1 divided by the 100th item will give you percentile 20. If you want 62, then n plus 1 divided by the 100th item. That's how. Now let's just come to the continuous series. Now in the continuous series, what is it? It is the class interval series. Now in the class interval series, what happens? You first find out in which class interval lies Q1. So what will you do? You will take sigma f divided by 4, that is n by 4th item, will tell you in which class interval does the first quartile lie. Once you find that out for exact one, then you use this formula, L1 plus n by 4, which you worked out, minus CF, previous frequency of the given class, into I. Exactly the way how we do the median. So Q3, so what do you do for Q3? This is, let me just tell you, 3 into n by 4th item will tell you in which class interval does Q3 lie. Okay. So, suppose you want to find out where does, say D1. So what do you do? In D1, what do you find out? You want, again in the continuous series, n plus 1, the size of n plus 1, the size of n by 10th item will tell you where D1 lies in the class interval. Okay. Now D7, 7 into n by 10, 10th item. Size of this will tell you in which class interval does D7 lie. And let's come to P1. Okay. Once you know, well, I got only D1 and D7, so let's just come. Once you worked out where D1 lies, then that class, and so you know which class interval it is. In that class interval, take the lower limit, L1, plus n by 10th, which you have already worked out, minus CF, the previous frequency of the cumulative frequency before the decile class, and then the frequency of the decile class, and into I, the difference between L1 and L2. And in the same manner, if you want to find out D7, 7, the size of 7 into n by 10th item will tell you in which class interval does D7 lie. And once you find out that, then take lower class interval of that, lower limit of the class interval, L1, plus 7 into n, this, whatever you got, you're going to put it there, minus CF, the previous one, previous cumulative frequency, divided by the frequency of the D7 into I. Okay, I'll also tell you one thing, like when you do, see, suppose when you do F in, if you add up the frequency of the class, D7 class, and the cumulative frequency of the previous one, if you add them up, you will get the cumulative frequency which is corresponding to the D7 class interval. Just go through it and see if you can do that. Now P1, let's just come to P1, P20 and P62. In the same manner, in the continuous series or the class interval series, you will work out n by 100th item, that is sigma f upon 100. Size of that will tell you wherein lies P1. Okay, in which class interval. Once you find that out, then you want to know exactly what is P1. So L1 plus n by 100, which you've already got, minus CF, preceding the median, the percentile class, upon frequency of the percentile class into I, the difference. And that goes on with 20 and by 100 will give you in which class interval does P20 lie. And once you find that out, you'll get L1 plus whatever value you got minus CF minus F into I. And P62, again the same. Now, let me ask you to do a question, which I'm going to do in the next class rather than, otherwise this class is going to become too big. Let's do this question for homework. Find out first quartile, third quartile, then 6th decile and 20th percentile from the following data. So this is the data: 2, 7, 9, 12, 8, 16, 20, 40, 25, 45, 25, 30, 25, 16, 11, 18, 27, 37, 39 and 42. So how many are there? 20 of them. So now first thing, just remember what you will do is you're going to arrange it in ascending order. Once you arrange it, then you can find this out. Now you know that this is an individual series, all right? So, and what do you have to do? Just n plus 1 divided by whatever it is. If it is Q1, n plus 1 divided by the fourth item. Q3 will be 3, n plus 1 divided by the fourth item. Then you want, what is this? D6. So you're going to write 6, n plus 1 divided by the 10th item. And if it is P20, yeah, it is 20. So 20, n plus 1 divided by the 100th item. That is how you will work this out. So happy solving, and in the next class I'm going to take this up, this numerical, and maybe we'll do one on continuous series.